Hello friends, this is Anand Pai from Academy in Pursuit of Engineering Excellence. Today I am going to start a new session, new type of problems. These type of problems are based on student recommendation. So if you want a particular problem to be solved, kindly recommend it on the comment section and I will be trying to solve it as fast as possible. This is Mr. Amit Kumar who has asked me this particular problem, and he is the first one to ask. So I started solving the problem just in 12 minutes. That means I have started just after he put it, I started working on it. So that's how fast I want to work. But as more and more recommendation comes, it is obvious that I will be slow in my responding. But I will see that in one video there will be one problem, and they have also recommended me to solve the full XE fluid mechanics, which also I will try. But first initially I will solve the individual problem, one problem at once. Whichever the problem which you feel it is difficult to solve, such problem I will solve. So please recommend which problems to be solved, whichever gate paper it may be, whether chemical, mechanical, civil, anything. You give me one single problem to solve, I will solve it for you and I will put it on my channel. Okay, so let us start with this problem. He has asked me to solve GATE XE 2018 fluid mechanics question number 14. So let us solve this problem. Okay, problem is like this: a water jet of 100 mm diameter issuing out of a nozzle at a speed of 50 meters per second strikes a vein and flows along it as shown in the figure. The vein is attached to the cart which is moving at a constant speed of 20 meters per second along a frictionless track. The jet is deflected at an angle of 30 degrees. Take the density of water to be 1000 kg per meter cube, neglecting the friction between the vein and the fluid. The magnitude of force exerted by the water on the cart in the x direction in Newton is. By the water on the cart. Okay, so that has to be understood, and magnitude they have given. Okay, so let us try to solve this. Now here what is important is only Newton's law. Okay, so Newton's law says force is equal to rate of change of momentum. So that is the main thing what is applied here. So now when you say momentum, mass m dot, if I cannot take it just like that outside, but m dot remains constant here, so I can take m dot outside. So I can say m dot into dv, change in velocity. Okay, now change in velocity, now if you see here we have to take the control volume approach. So what is the force exerted on the control volume? So what is coming in and what is going out, like that we have to take dv. Okay, so force is equal to m dot into dv, or v2 minus v1. Okay, so the theory related to that we will solve it later. First we will try to solve the problems. Okay, so that it will be helpful for you to for the people of GATE 2021 who are preparing for GATE 2021, for them it may be helpful. Okay, so what is m dot? M dot is density rho into area into velocity. Now here, and this may be v2 and this is v1 I will take. So what is the velocity which is to be there? It has to be v2 minus v1, correct? dv is final minus initial, so it is v2 minus v1. Now one of the thing what has to be taken is, what is that we have to take? We have to take v1. Next, that is the rate at which the water is coming. Now what is the velocity that has to be taken? Whether it has to be taken 50 meters per second or the 20 meters per second, what has to be taken? It is a difference that has to be taken. It is a relative velocity that has to be taken. So there might be a mistake that people may take for this mass flow rate. Here they will take 50 meters per second. Do not take that. Take this v1 as 50 minus 20. So v1 is relative velocity, very important. This is relative velocity, and relative velocity here is 50 minus 20, so many meters per second. So now my force is equal to rho a v1. Rho a v1 is, rho is given as 1000 into area is pi into 0.1 square divided by 4, and what is the v1 we have to take? V1 we have to take 30, which is the relative velocity, V2 is 30 cos 30 because you are taking along the x direction. Okay, so 30 cos 30 minus 30, so many things. So this force you will actually get it as minus 947.01. Now here this is the force exerted by the fluid on the vane or vane on the fluid. Here we are seeing the change in the momentum of the fluid. So it is the force exerted by the vane on the fluid. Very important. It is the force exerted by the vane on the fluid. Force of the vane on fluid. So what is the force exerted by the fluid on the vane? So fluid on the vane, it is F is equal to 947.01, so many newtons. That would be the answer what I am getting. Now here one thing we have to keep in mind is, here they have given the magnitude. So whether it is 947 you should not take minus. But in case they did not give the magnitude, then if you say minus 947 as the answer, it is wrong. It should be plus 947. So the force exerted by the liquid on the vane is plus 947.01 Newton. I hope you have understood this, students. Thank you very much, and further recommend me whichever problems I have to solve based on fluid mechanics. I will solve it. Okay, whether I have completed those portions in my theory videos or not, I will solve the problem. So I will give the preference to the problem. So kindly share these videos, kindly subscribe my channel and press the bell icon so that you could get the notifications. Thank you very much, students, and best of luck for GATE 2021. Thank you.